Hi everyone, in this video I'm going to basically show the solutions for the first test, which was on transformations, compositions, and inverse functions. So let's start with paper 1, section A or part A. Fill in the blank. When in doubt, draw it out. Always is very, very helpful. Okay? Alright, so let's start with this one. Let f of x equals that, let g of x equals that. Find g inverse of x. So when you need to find the inverse, you just simply switch the x and y. So really y is equal to x plus 3 square root. Switch the x and y, so y plus 3 square root there, and now just solve for y. So you have to square both sides in order to get rid of that square root. So it becomes x squared is equal to y plus 3. Then you just basically y is equal to x squared minus 3. And since we're trying to find g inverse, we'll just do this final step, is equal to x squared minus 3, and that's our solution. Now, find f of g of negative 3. So if you ever want to do this, first find what f of g of x is. Just makes it easier from my point of view. But and g of x is square root, so it's f of square root of x plus 3. And since this is the argument, you take this argument and plug it into the x over there. So it's 2 times square root of x plus 3 squared. So this becomes 2 times x plus 3. So that's what f of g of x is, but we want to find f of g of negative 3. So basically what I'll do right now is f of g of negative 3 is equal, so I'm just going to isolate that there, is going to equal to 2 times negative 3 plus 3. So it's equal to 2 times 0, which is equal to 0, and that's our answer for B. So 0 is the answer for B. Let's do part C. Write down the range of G inverse. Now remember that the range of the inverse is the same as the domain of the original function. So remember, when in doubt, as I mentioned over here, when in doubt, draw it out. So let's just draw out what g of x would look like. So g of x, we've said, is the square root of x plus 3. We know that this is a square root function. And what this means, it's a shift to the left by 3. So it's negative 3, and it'll go like that. So let's write down the domain and range of this. So the domain of this is x is going to be greater than or equal to negative 3. And the range here is y is greater than or equal to 0 because it basically starts at 0 and goes up. So the domain of this function is the range of the inverse. So to answer this question, what is the range of the inverse? The answer to this is simply the domain of the original function. So the answer to this is y is greater than or equal to negative 3, and that's our answer. All right, so I hope that's clear as to why that is the answer over there. Okay, so let's move on to the next question. Number 2, the graph of f inverse is shown here. On the same graph, sketch f of x. So in other words, f inverse and f of x are inverses of each other. So all we have to do is just get an xy plot and switch them. So here's what I mean. So let me just get a few points. So let's get an xy plot right here. So this plot is, this point right here is negative 4, negative 5, negative 4, 1, 2, 3, 4, 5, negative 4, negative 5. Let's get another point here. That looks like, roughly speaking, negative 2, 0. And I'm just going to get one more point, which is right here, which is 3 and 4. So it's 3 and 4. So all you really need is just about 3 points and you're good to go. So since we need to find sketch f of x, so basically that's the inverse function, since that's what we're trying to sketch, all we have to do is switch x and y. So this is going to be negative 5, negative 4, 0, negative 2, and 4, 3. Okay? So basically I'm just going to plot that right here. I'm going to use black this time. So negative 5, negative 4, 1, 2, 3, 4, 5. Negative 5, negative 4 is 1, 2, 3, 4. So that's basically 1 point right there. 0, negative 2. So 0 on the x and negative 2 here. Negative 2 is right there. And then 4, 3, 1, 2, 3, 4. And then 1, 2, 3 is right there. So basically, this is going to end up looking something like this. And that black line right there is f of x, which is the inverse of f inverse. And now, write down the range of f of x. So if you look at the question, they have given us the domain. The domain is negative 4 to x, x is between negative 4 and 3. So the range, so remember, the domain of one function is the range of the inverse, of its inverse. So the range of its inverse here is simply negative 4, but this time it's y to 3. And that's how you do b. And that's, okay. So we're done with this one. Number 3, this is one of the questions I gave in the package, but let's just do it again. The package that I gave you a long time ago. So find f of g of x. So this is straightforward. So this means f of g of x, which is f of x minus 1. And you take this argument, x minus 1, and you plug it right into that x over there. So it's simply something squared plus 4, and that something squared happens to be x minus 1. Now, you might be tempted, and this is actually it, that's all you have to do. And you might be tempted now to expand this, but you don't have to. They just said to find what this is, and this is sufficient. And in fact, this form is actually very useful in the next section. So, the vector 3, negative 1 translates this graph, f of g, so this is our f of g, to the graph of h. Find the coordinates of the vertex of h. So, the important thing here is what we're doing is we are going from f to h. And how are we going from f to h? We're doing a translation. We're moving 3 to the right and down 1. So what the important thing to do here is when you're going from f to h, you should be able to write h of x in terms of f of x. And so what do we need to do to f in order to get h? Well, we have to move 3, and we're not, my mistake. It's not f that we're moving. It's f of g that we're moving. And this right here is f of g. So what do we need to do to f of g in order to go to h? So right here, it's pretty simple. We have to move 3 to the right. So if we have to move 3 to the right, that's just x minus 3. And then down 1, and that's simply minus 1. So you do this first, and then you go down 1. And recall, once again, this is our argument. And this is already f of g. So all you do is you take this argument and you plug it in right there into that x. So let's see what that looks like. So it's equal to, I'm going to write this in red, so it's going to be x minus 3 minus 1, okay, squared. Don't forget, this whole thing right here is f of g, so we cannot forget the plus 4. That plus 4 is still there. So what I mean to say is that this part right here is basically all of that. So we have to finish writing this part first, and then at the end, we're going to tack on the minus 1. So it's minus 1. So if I go further down, what this is x minus 3 minus 1, that's simply x minus 4 squared, and then plus 4 minus 1, that's simply plus 3. So the question said find the coordinates of the vertex. So based on this, we know it's moved 4 to the right, up 3. So the coordinates of the vertex are simply 4, 3. And that's the answer for this one. Okay, number 4. So let f of x equal some big function. Okay, don't worry about that big function. This is a paper 1 question. I highly doubt they'll ever ask you to solve something using this, but they might. But anyways, but let's read the question. The function f has a minimum point a, negative 2, negative 8. So here's a point on this function. Now, write down the image of a after reflection of the x-axis. So whenever they ask you to find the image, just draw a little table. Draw a little table like this. So this is simply negative 2 and negative 8, right? And now they've said the image of a means after you've done some sort of transformation, that's what the image of a will be. And there's a reflection in the x-axis. So whenever there's a reflection in the x-axis, the only things that are affected are the y's. So it's x and negative y. So the x doesn't change, but the y does. So it's negative 2, 8, because negative 8 times negative 1 is 8. So our solution is negative 2, 8, and that's it. So we're done with A. Let's do B. Write down the image of A after translation of -3, 4. So all it's saying is you have to move 3 to the left and 4 up. That's it. So once again, we can take the same approach, -2, -8, right? And since it's just 3 to the left, you just do x minus 3. A lot of people were really confused by this. Like some people put x plus 3, and we don't do that. Whenever you see a vector form, you just simply, it's telling you what to do. So you simply move 3 to the left, which means you subtract 3 from x, and you move 4 up, so it's y plus 4. So -2 minus 3 is -5, and -8 plus 4, -8 plus 4 is actually -4 because you're reducing the negative, so -8 plus 4. So the coordinate here is -5, -4. Okay, and that's it. Okay, now write down the image of A after reflection in the y-axis, followed by a horizontal stretch with a scale factor 2. So y-axis, horizontal stretch factor of 2, and a vertical stretch of 3. Okay, so let's do this. So once again, it's really straightforward. It's simply the xy plot. Now, a lot of people know a reflection in the y-axis means that the x's are being affected. So there's definitely going to be a negative here. Now, this says a horizontal stretch by scale factor 2. So a lot of people thought that because I said horizontal stretch factor, I have to write half here. But that's not true. That's not correct. Because whenever I just say horizontal stretch factor and I'm dealing with this table, you simply write down the information that you're given. So this will simply be 2. Okay? So it's simply 2x, and vertical stretch factor by 3, so it's 3y. The only time where we have that counterintuitive principle is when we have it in f. So say, for example, if I had to write horizontal stretch factor of 2, the way I would write it in as a function, it would be half x. Because a horizontal stretch factor of 2 means f of half of x. So anytime you have this f or g or in function form, that's when you sort of do the reciprocal. Or we have that counterintuitive that left is plus and right is minus. And that's only within the function and if we have an f or g or whatever else it is. But if I ever write in a table, I don't have to worry about that. So I'm just going to erase this. So just keep in mind that the only time when you have a horizontal stretch factor of 2 and where you have to do the reciprocal or anything like that is when you have it in f and vice versa. If you have it in f and you want to write horizontal stretch, you have to do the reciprocal. But in this table form, you don't have to worry. If you read it correctly, it's fine. So this is -2 times -2, so that's 4. -8 times 3, so that's -24. And so our coordinate is 4, -24, and that's our solution. Okay, so the graph is shown below. You have these 3 points A, B, C. Write down the slope at x equals -3. So at x equals -3, so which is here, at x equals -3, we want to find out the slope. So the slope will just be on this line AB. So how do we find the slope of AB? So the slope of AB is simply, if you remember the formula, actually I'm going to write it here just so I have some space. So m equals y2 minus y1 over x2 minus x1. Okay, y2, so basically we're just taking a and b because it's just lying on this line. So it'll be 2 minus 5 because this is y2 minus 5. So it's 2 minus 5 over -1 minus -5. So -1 minus -5. So this is equal to 2 minus 5, which is -3. -1 minus 5, it's going to be -1 plus 5. So it's going to be -3 divided by 4, and that's our solution. So it's -3 divided by 4 because -1 plus 5 is 4. So our solution for this one, write down the slope, it's simply -3 over 4. And it makes sense. It has to be negative because it's downward sloping. And so it's 3 over 4, and that's simply it. Okay. Now, let's do the second part. On the diagram below, draw the graph of y equals f of 2x. So the first thing that we need is we have our 3 points, right? We have our ABC, which is -5, 5, -1, 2, and 3, 7. So let me write that down. So here's our xy plot. -5, 5. Let's see, what else is there? negative 1, 2, and 3, 7. Okay, so negative 1, 2, and 3, 7. Okay, so so now if I want, basically you just have to create your x-y plot. So this negative here, since it's on the outside, it means it affects the y's. And there's no vertical stretch, so it's simply negative y. Now f of 2x, what it means is that it's a horizontal stretch of a half. Remember, whenever it's in the f, that's the only time you sort of like do that reciprocal, so it's half x. So all we're doing is it's negative 5 times half, which is negative 2.5. I'm just going to do the x's first. Negative 1 times half is negative 0.5, and 3 times half is 1.5. Okay, what about, since this is negative, this is just negative 5, negative 2, negative 7. So let's plot these points. So negative 2.5, which is right here, and negative 5, 1, 2, 3, 4, 5. So we have 1 point right there. Negative 0.5 and 2, so negative 0.5 and negative 2, which is right there. And 1.5 and 7, so 1.5 and negative 7, sorry. So that's somewhere right there. And all you have to do is just connect these dots right there, and connect that dot right there, and that's basically our graph. And that sort of makes sense. If you take a look at it, what's happened? This function says that you have to do a reflection across the x-axis. And so if it looks like this, a reflection across the x-axis will definitely look like that. And there's a horizontal stretch by half, so which means all the x points are stretched by half. So this looks a little bit compressed. So that's our solution for this one. So we're done with B. And now C, the point A maps to A prime on the graph y equals blah, blah, blah. Find the coordinates of A prime. So once again, we just do the same thing as before. Let's figure out what A was again. A was negative 5, 5. So it's negative 5, 5. Now, if I translate, or what's transformations, it's negative f of x. So that means it's this negative y. And it's plus 1. It's affecting the y's only. It's plus 1. So, and x does not change at all because there's nothing inside the, well, besides x, there's no other compression or anything like that. So this is simply negative 5, and this is negative 5 plus 1. So that's negative 5 plus 1, so that's negative 4. So our coordinates, our answer is negative 5, negative 4. Okay, and that's it for C. Okay, let's do number 6. The graph below shows parts of the graph of y equals root of x and that. And if we read the question, the graph of y equals square root of x may be transformed into this graph. So in other words, we're going from this graph here to that graph there by these transformations. So there's a reflection across the x-axis, a horizontal stretch of the scale factor of k, a horizontal translation of p, and vertical translation of q. And the question basically asks to find what are k, p, and q. Okay, so the best way to do this is you must remember that you must always factor. So the first thing you should do is, before factoring, is rearrange. So if I rearrange this, this is 3x plus 6 plus 5. And then if I factor, it's simply 3x plus 2 plus 5, right? And if you look at this, what this means is, first, you see this 3, it's inside the function. And since it's inside the function, that tells you that we have a horizontal stretch by a factor of 1/3. Okay, you must remember, because it's inside the function, you take the reciprocal of it, so it's 1/3. And the reason why it's not negative 1/3, it is not negative, because the reflection in the x-axis, that takes care of it. This negative is associated with this reflection across the x-axis. So make sure that the stretch is never, ever negative. It's always, always positive. Now write down the value of p. Now p is the horizontal translation. So this is associated with the horizontal translation. And since this is x plus 2, it means it's 2 to the left. So p must be negative 2. And finally, the last one is write down the value of q. Q is plus 5, so it's a vertical translation. And so, in other words, this is simply 5. And we're done. All right, so now we'll move into part B, section B. So here's a sketch that shows y equals f of x, which passes through these points. A second function, g of x, is defined by that. So in other words, g of x is basically a transformation of f of x. And this says, give a full geometric description of the transformation that maps f to g. So you must remember that if you're mapping one to another, always factor. So this is really just f to x plus 2 right there. So this is the factored form. So what does that mean? So this 3 right here tells you that there's a vertical stretch by 3. This 2 over here tells you that there's a horizontal stretch by 1/2. Okay, by 1/2. And if you look at the last one, it's x plus 2, so which means it's 2 units to the left. So all you just say is left 2 units. And you're done. That's the full geometric description that maps from f to g. Okay, now show that g inverse g of -1 is 0. So whenever you hear the word show, another really meaning for that is prove. So really prove that g inverse, g of -1 is equal to 0. So the argument of g is -1, right? And what is g? It's simply 3 times f of 2 -1 plus 4. And what that is equal to is 3f of, what's 2 times -1? It's -2 plus 4. And don't forget this f. Never ever forget this. This f is a function. What this really means is this is 3 times whatever this output is. Here's the input, -2 plus 4, and the output is f of that. So this is basically 3 times f of 2. Now what does this mean? Like I just said, this right here, maybe I'll use a different color. So, oops, sorry. So this is f of 2. So what does this mean? This means that the input is 2 and f of 2 is the output. Now, what is f of 2? So the only way to determine that is by looking at the graph. Let's look at what f of 2 is. So if we look over here, this is your input. This is your input. The x's are your input, and your y's are your output. So f of 2, here is x, when x is 2, what is y? Y is simply 0. So in other words, what is, let me just scroll down a bit. In other words, what is f of 2? F of 2 is simply 3 times 0. Because we just have to look at the graph each time and determine what, for a given input, what f of 2 is, or whatever the f output is. So 3 times 0 is 0, and thus we have proven or shown that g of -1 is simply equal to 0. Please make sure that this is g of -1 and not g inverse. It's the argument here is -1. Now, find g of -3. Now, this is basically the same thing, okay? So we do 3f of 2 times -3. This -3 is simply comes from the argument over here, plus 4. And this is 3. Now, again, don't forget the f. The f is the most important thing right here. Don't just ignore it. So this is -6 plus 4. And this is 3 times f of -2, right? So in other words, we have to find out what this value is. And the only way to determine that is to go back to the graph and see what it is. So f of -2. So let's go back to the graph and let's look here. F of -2. So f of -2, if you look kind of over here, it's kind of -1.5. If you look over here, this point, roughly speaking, is -1.5. So, sorry, f of -2, sorry. F of -2, sorry, my bad. It's right here. So f of -2 is really this point right here, this green dot right here. And if you look kind of carefully, it's actually equal to almost -1.5. So f of -2 is, when this is -2, when x is -2, y is -1.5. So what I'm going to say is this is basically equal to 3 times negative 1.5. So 3 times negative 1.5 is negative 4.5, and that's our solution. So all you have to do is find what f of negative 2 is, get the actual value, and then multiply it, and then you're done. So we're done with C. Now, number 2. This was a little bit hard, but I think once you see it, you'll see how straightforward it is. So here is my f inverse of x function, and here's my sort of xy plot. So what it's saying is that for f inverse, when x is 2, y is 3. So how does that translate for, we are trying to find what f of 3 is. So how does that translate for f of x? Well, you recall that these are simply inverses of each other, which means the x's and y's simply switch. So if in this case x is 2 and y is 3, in the inverse, this must be the exact opposite. So it's 3 and 2. And now the question says, write down the value of f of 3. So in this case, just based on this, f of 3 must be equal to 2. And that's it. This is our solution. And so this works always for any case. So say I'm just going to write a different example. So say, for example, I write f inverse of 4 equals 5, and I ask you, what is f of 5? F of 5 must be equal to 4, because they're simply inverses of each other. Let's say if I write f of 3 is equal to 7, right? Then f inverse of 7 must be equal to what? 3, because that's just exactly how it works. They simply switch. So let's do one last example. If I say f, if I do f inverse of 7 is equal to 11, what is f of 11? It must equal to 7. And that's exactly it. So you're simply switching the x and y's, and that's what the inverses are doing. So let's get rid of this. Those were just examples. So let's get back to this equation. Now find f of x. So here's f of x, and here's the slope, right? So m, as we know, is simply negative 3. So f of x is simply equal to negative 3x plus b. So if we want to find f of x, we need to basically find b. We don't know what the y-intercept is. So in order to find what f of x is, we just need 1 point. And we've already determined that f of 3 is equal to 2. So in other words, when x is 3, y is equal to 2. So this right here is simply 2. This x over here is simply this 3 over here, so it's 3 plus b. So 2 is equal to negative 9 plus b, which means that b is equal to 11. So because if you add 9 on both sides, 2 plus 9 is 11. So what is f of x finally? F of x is simply negative 3x plus 11. And that's our solution. And that's it. That's a lot simpler than maybe you originally might have thought. Okay, and finally, let's do this one. Hence or otherwise, find f inverse of x. So we know, we just determined that f of x is equal to negative 3x plus 11. So in other words, if we want to find the inverse, this is simply negative 3x plus 11. Switch x and y. X is equal to negative 3y plus 11. And then this becomes x minus 11 is equal to negative 3y. So y is equal to x minus 11 divided by negative 3. So f inverse of x is finally x minus 11 divided by negative 3. And that's it. That's how you do C. Okay? All right, let's move to the... All right, so now let's move on to the last question of paper 1. Okay, so here they say that there's a point A, and it's on the function f, and it's mapped to a prime. It's in the function g. And so this function f is mapped to g through these transformations. So let's just write them down. Basically, we have a horizontal stretch, and it's by p. There's a horizontal translation, which is by q. There's a vertical stretch, which if we look over here, vertical stretch by q. And then there's a vertical translation, which is by p over here. Okay, so I know that you've never seen this type of question before, but in a way you actually already have. So let's say, for example, that instead, so I'm just going to write this in red. So I'm going to show you an example, and then I'll show you how to do A, B, C, and D. So let's say, for example, we have -6, -2. So basically this point. And we want to find out what it maps to, right? So let's say instead of these letters, I actually put some numbers in. Okay, so I actually put some numbers in. So let me put some numbers. Let me put some numbers like 4 and 5 and 5 and 4, right? So I have a horizontal stretch of 4, horizontal translation of 5, vertical stretch of 5, vertical translation of 4. So how would I find out what point it maps to? So what I would do in this case, I would take my x-coordinate, -6, and since there's a stretch of 4, what I'm going to do is I'm going to multiply it by 4, right? I'm going to multiply it by 4, and then I'm going to add 5 because it's a horizontal translation of 5, right? And that's going to equal to, this is going to be -24 plus 5, so it's going to be -19. So right now, I already know that point is -19, right? And then I'm going to do the same thing with the y's. I'm going to take the -2 multiplied by 5 and then add 4. So -2 times 5 is -10. And -10 plus 4 is -6. So that's how I would do it if I had those values. Now, let's change things. Well, we don't have those values. We have PQ, PQ. So basically, I'm going to change that to, so let's say that's P, that's Q, and that's Q, that's P. So the other thing that we know is that this is not the point. It's mapped to -9, -4. So this is going to be, let me just put this in blue, -9, -4. So I did this using the x-coordinate, so there's no longer 19. This is going to be equal to -9. Now remember, previously I had 4 and 5 over here, which is why I have 4 and 5 over here. So let's do this without maybe the 4 and 5. So we're going to replace this. So basically what I do is I take the -6 multiplied by P and then add Q. So that's what I'm going to do here. So it's -6 multiplied by P plus Q. And it's going to equal to -9. So this -6, I'm going to do something to it such that it ends up at -9. So what am I going to do to it? I'm going to take the -6 multiplied by P and then add Q, right? So I'm just going to erase it just to basically show you exactly what's happening. So I'm going to take this -6 right here, and I'm going to multiply it by P, right? And then I'm going to add Q, and I know that it's going to equal to simply -9. Now, let's look at this question. Using the x-coordinate of A, which we've done, we use the x-coordinate of A, show that Q is equal to 6P minus 9. So in other words, we have to solve for Q. So it's -6P plus Q, so Q is equal to, so if I add 6P to both sides, it's 6P minus 9, and we've done. Remember, now what's another word for show? It's just prove. Prove. So we've just basically proved that this is equal to, Q is equal to 6P minus 9, and we're done with A. Now with B, using the y-coordinate of A, find another expression for Q in terms of P. First of all, what does this mean? This means when they say find for Q in terms of P, basically Q has to equal something and there has to be a P involved somewhere. So whenever they say for something in terms of something else, start with Q equals blah 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 and something in terms of P and then just go from there. Okay, so anyways, let's solve this. So now using the y-coordinate, basically we're taking -2 because that's the y-coordinate, so -2. And we're now going to use the vertical part because the y-coordinate is only affected by the vertical. So it's -2 times Q, that's the vertical stretch, plus P, right, must equal to, what does it map to eventually? -4. So it's -4. And that's how we do it. Now it says find it a Q in terms of P. So basically we have to solve for Q. So it's -2Q is equal to minus P minus 4. And then Q is equal to minus P minus 4 and divided, the whole thing divided by -2. So that's the solution for part B. Now, Hence or otherwise, find the value of q. So the thing is, if you want to find the value of q, we have an expression for q over here, and we have an expression for q over here. So I'm going to take this q and equate it to that q over there. So q equals q. And so it's this q over here is 6p minus 9. And that q over there is minus p minus 4 divided by negative 2. So what we have to do here is let's try to solve p, because now we can solve p. So we can multiply by negative 2 on both sides. So if I multiply by negative 2 on both sides, this becomes negative 12p. And negative 9 times negative 2 is simply plus 18. And since I multiplied this side by negative 2, this is simply minus p minus 4. And then if I solve for p, if I bring all the p's to one side, it's negative 11 p is equal to negative 22. So p is equal to negative 22 divided by negative 11, which is equal to 2. The question said find the value of q. So we found the value of p, so we didn't find q. So if you want to find q, all you have to do is just take it and plug it into any one of these equations that we have. I'm going to pick this one because this looks a little bit easier. So we already have p, so we know that q is equal to 6p minus 9. 6p minus 9. So, and we know that p is equal to 2, so 6 times 2 minus 9, which is equal to 12 minus 9, which is equal to 3. So q is equal to 3. Okay, and find the value of p. Well, we already did that over here, so p is equal to 2, and that's our solution. So q is equal to 3, and p is equal to 2. So, but the most important thing about this question is basically setting it up. How do we get that equation? So remember, negative 6 times p, because that's the x times the horizontal stretch, and then you're adding the q, and then you end up with negative 9. And that's how you get one equation. You get a second equation with the y, and that's how you end up solving p and q. Okay? All right, so now we move on to paper 2. All right, so here's our equation. It's a quadratic. F of x is equal to x minus 3 squared plus 1. Find f inverse. Same deal as always. So we say this is x minus 3 squared plus 1. So switch x and y if you want to find the inverse. So x equals y minus 3 squared plus 1. What we're going to do is we're going to subtract negative 1 from both sides. So or we're going to subtract 1 from both sides. So it's x minus 1 is equal to y minus 3 squared. And if to get rid of that squared, I have to square root both sides. So it's going to be x minus 1 square rooted is equal to y minus 3. And finally, y is equal to the square root of x, or square root of x minus 1, plus 3, and, oh, actually, this is not my solution. Sorry, it's not my solution. My solution is f inverse of x is equal to the square root of x minus 1 plus 3, and we are done. Right? Write down the range of f inverse. Well, we have the domain of f of x, and remember, the range of the inverse is the domain of the original function. So if this is x is greater than or equal to 3, so this is y is greater than or equal to 3, and we're done. Okay. All right, so let's move on to number 2. So this says f of x is equal to x minus 3. So first question says find f inverse of x. So this is straightforward. Y equals x minus 3. So you just have to switch x and y. So x equals y minus 3. And so y equals to x plus 3. So f inverse of x is simply x plus 3. And we are done. Okay, now find g of f of 2. So first, always just find g of f of x. It's just a good practice, personally speaking. So g of f of x is simply g of f of x. And that's g of, what's f of x? It's x minus 3. X minus 3. Now remember, this is the argument. This is the argument. And it goes right into over there. Just right into that one over there. So this is equal to x minus 3 squared minus 1. Now, we're not interested in finding x minus 3 squared minus 1. What we're interested in is finding what g of f of 2 is. So g of f of 2 is simply, you just have to plug in 2 over there. So it's 2 minus 3 squared minus 1. So that's negative 1 squared. Negative 1 squared is simply 1 minus 1, and it's equal to 0. And so the answer for this one is 0. Okay? All right, so now let's move on to number 3. So find, here's f of x and here's g of x. Find f inverse. So this is straightforward. So if you want to find f inverse, let's take a look at f. It's simply 3x minus 5. So you just switch x and y. So 3y minus 5. Now we solve for y. So it becomes x plus 5 is equal to 3y. It's x plus 5 because I just added 5 to both sides. And now if you want to solve for y, it's x plus 5 divided by 3. And so our final answer is simply f inverse of x is equal to x plus 5 divided by 3. So that's the solution right there. So we're done with A. Now B. Given that g inverse of x is x plus 2. So here's g of x, and they're telling us what g inverse of x is. So we don't have to solve for a g inverse. Find g inverse of f. So all this means is, here you go, here's g inverse of f of x. What is f of x? It's 3x minus 5, so g inverse of 3x minus 5. So this is the argument. And you might think that, oh, I have to plug this argument into here, g, but no, look, this is g inverse. And here's our g inverse. So you want to plug it right into this x right here. So this is equal to something plus 2. And what is that something? It's this argument right here, 3x plus 5. And this can be simplified to 3x, oh sorry, I didn't mean to say plus 5. This has to be minus 5. I didn't look. So anyways, what's minus 5 plus 2? That's going to be minus 3, and our solution is that. So that's it for B. Let's do C. So given also that f inverse of g is that, and solve, okay, it says solve. So basically, solve, and so in other words, set this equation to that equation over there. So they're telling us what f inverse of g of f of x is. So they're saying that's equal to x plus 3. So this side over here is x plus 3 over 3. Now what about this side? This is g inverse of f of x. G inverse of f of x, we just found it out. We found it out, oh, we found it right here. G inverse of f of x, which we said was 3x minus 3. So this side right here is simply 3x minus 3. And now, whenever they say solve, it just means find x. So all we have to do is solve this equation and find x. So what we can do is multiply both sides by 3. So it becomes x plus 3 equals 9x minus 9, because each of these get multiplied by 3. And now, just bring all the x's to one side and the numbers to the other. So this will be 3 plus 9. 3 plus 9 is equal to 9x minus x. So this is 12 is equal to 8x. And so x is equal to 12 divided by 8, which is also 3 over 2, which is also 1.5. And that's our solution for this one. All right, let's move on to the next one. All right, so this was a really, really good, interesting question, which number 4, which you really, really need to understand. Okay, so let's take a look at this question. So A is a part of the graph of y equals, I'm just going to write this down, y equals square root of x plus 1 plus 2. Okay, so that's A right here. B is part of the graph of y equals x. So this is simply y equals x. And C is the reflection of A in line B. So you must remember that whenever you see y equals x, and whenever you hear the phrase reflection, okay, a reflection across y equals x, you need to know that the relationship between A and C is what? Is that they're inverses of each other. The inverse is always a reflection across y equals x. So the relationship between A and C is that they are inverses of each other. So A is the inverse of C, and C is the inverse of A. Okay, so that should be screaming at you, and that'll come up later in the question. But first, let's do part A. So write down the y-intercept of graph A. So in other words, the y-intercept of that point right there. So the y-intercept of any graph is when x equals 0. So first we have to plug in x equals 0 and solve for y. So let's do that. So y equals 0 plus 1. And this works for any equation. It doesn't have to mean the square root. Whenever they ask for the y-intercept, it means x equals 0. And vice versa. If they ask for the x-intercept, it means y equals 0. So anyways, let's just solve this. So it's plus 2. So this is 0 plus 1 square rooted, so it's the square root of 1 plus 2. What's the square root of 1? It's simply 1 plus 2, which is equal to 3. So the y-intercept is simply 3. And if I had to write that as a coordinate, the coordinate of that would be 0, 3. Okay? So the y-intercept is 3, and the coordinate of that is 0, 3. Now, find the equation of c in the form y equals f of x. So it's some function with the domain. Okay? So what did we just learn from this graph? We learned that a and c are inverses of each other. Now, do we have the equation of a? Yes, we do. So how do we find c? We simply find its inverse. And that's it. That's really all what that means. So we have y equals the square root of x plus 1 plus 2. So if we want to find c, we just have to find its inverse. So x equals the square root of y plus 1 plus 2. And now the first thing you should do is you should subtract the 2 before you do anything to the square root. So it becomes x minus 2 is equal to the square root of y plus 1. You square both sides. So it becomes x minus 2 squared is equal to y plus 1. And then it becomes y is equal to x minus 2 squared minus 1. Now, look at the last half of the question. It said with the domain. So let's basically look at this and figure out what the domain and range of the original function is. This is minus 1, it's plus 1 over here, so which means that it's moved to the left negative 1, and it's plus 2, so which means this is 2 right here. So what's the domain and range of this function? Well, the domain has to be x is greater than negative 1, x is greater or equal to negative 1. And what's the range of this function? Well, y has to be greater or equal to 2. So remember, since a and c are inverses of each other, and I'm asking to find the domain of c, the range of a must equal to the domain of c. So what's the range of a? It's y is greater than 2. So what's the domain of c? It's going to be x is greater than or equal to 2. So the solution to this one is the domain right here, is x is greater than or equal to 2. Okay? So that's how we do that one. Now, write down the coordinates where the graph of c cuts the x-axis. So let's look at the graph over here. So here, we basically found what the y-intercept was, and we found that it was 3. We found it was 3. So the y-intercept, since a and c are inverses of each other, this point right here would immediately map to this point right here, because the y-intercept of one graph will be the x-intercept of its inverse. So if this coordinate, we said this coordinate, let's do that in red, this coordinate is 0, 3. So immediately, what is this green coordinate here? Well, if it's the inverse, the x and y flip. So this must be 3, 0. So what is, write down the coordinates of where c cuts the x-axis. Well, c cuts the x-axis right here. We just found that's 3, 0. So the answer for this one is simply 3, 0. And that's our solution. All right, so keep in mind that whenever we see this y equals x, whenever you see y equals x, it's a big clue that we're probably most likely going to be dealing with inverses over here. All right, let's deal with this one. So let h of x equal that, and k of x is that. Okay, find k of h of 5. Okay, so the first thing you should do is probably just find k of h. It's k of h of x, right? So this means k of h of x. And what is h of x? That's 5 minus 4. Oh, 5x minus 4. So it's k of 5x minus 4. So what is this? This is simply the argument. And where does this argument go? there are two, it goes into k, but there are two x's, so it goes right into each of them. It goes into this one right here and goes into that x over there. So let me show you what I mean by that. So it's 2 times something, I believe it's minus 3. Yeah, yeah, it's minus 3. And then over something minus 4. And what is that something? It's 5x minus 4. And this is also 5x minus 4. So it's equal to, this is going to be 10x minus 8, 10x minus 8 minus 3, all over 5x minus 8. So if I simplified, this is going to be 10x minus 11 over 5x minus 8. Now the question didn't ask to find k of h of x, it says k of h of 5. So I'm going to write a little squished for space. I'm just going to do this here. K of h of 5 then is simply, you have to plug in 5 over here. So it's 10 times 5 minus 11 over 5 times 5 minus 8. And this is equal to 50. I need some more room here. So it's equal to 50 minus 11 over 25 minus 8. And 50 minus 11 is equal to 39. And 25 minus 8 is equal to 17. So the answer for this one is 39 over 17. So because I need some room, I'm just going to erase this, but I'm going to write the answer to this is 39 minus 17. So the answer to, so k of h of 5 is 39 over 17. And that's our solution for A. Now, solve k of h of x. So we basically found what k of h of x is, which is right here. So and it's equal, so in other words, this expression right here is that right there. So 10x minus 11 over 5x minus 8 is equal to 0. So what I'm going to do is I'm going to basically multiply both sides by 5x minus 8. I'm going to multiply this side too by 5x minus 8. So when you multiply both sides by that, this will cancel out, and what you're left with is simply 10x minus 11. So you're left with 10x minus 11. And what's 0 times anything? It's simply 0. So 0 times that is simply 0. So therefore, 10x is equal to 11. And what is x equal to? It's simply 11 over 10. And that's the solution for that one. Now, let's do this one. H inverse so basically, so this is h inverse of 6. So basically, we have to find this value and that value and just add them together. So first, we have to find h inverse of x. Right? We have to find that. So we know that, let's look up, what was it again? Let me see. H inverse was 5x minus 4. So really, we have to find the inverse of that. So y equals 5x minus 4. We want to find the inverse, got to switch x and y. So x equals 5y minus 4. It becomes x plus 4 is equal to 5y, and y is equal to x plus 4 divided by 5. So h inverse of x is simply x plus 4 divided by 5. Now, we want to find h inverse of 6. So h inverse of 6 is equal to 6 plus 4 divided by 5. So it's 10 divided by 5, which is equal to 2. So we got this one. Now we need to find k of 3. So k of 3 is equal to, what is k again? It's, k is 2x minus 3 over x minus 4. Okay, so k of 3 is 2 times 3 minus 4 divided by x minus 4. So that is equal to 6 minus 4, 6 minus 4 over 3 minus 4. And that's equal to, wait, I don't think this is right. Did I get that correct? Was it 6 minus? 2x minus 3, sorry, it's 2x minus 3. So I made a small mistake here. So it's 2x minus 3 over here, and it'll be 3 over there. So 2x minus 3, 2x minus 6 minus 3. So that's equal to 3 over negative 1. So this is equal to negative 3. Right? So we've got our h inverse there. We got our k of 3 over here. So now we just need to add these two values up. So the solution to our problem is simply, I'll just write this here. So h inverse of 6 plus k of 3, and that's equal to 2 plus negative 3, and that's equal to negative 1, and that's our solution. Okay, so let's do this one. Now we're in part B. So the following diagram shows part of this graph, okay? Its image y equals g of x is not shown, and after translation by h of k, which we don't, and we're not told what h and k are, has a vertex of 1, 2. Okay, so the first thing you need to do, like before we even start this question, before you even read what the questions are, is rearrange this. Always make sure that it's a nice, clean way of understanding this. So if I have to rearrange this, it's going to be negative x plus 2 squared plus 4. Okay, and that immediately tells me that there's a reflection across the x-axis, to the left 2 and up 4. And that's basically what we can see here. The left 2, up 4, and that's how we get this graph. Now, if we look at this, let's look at part A. On the same diagram, sketch and label g of x. So g of x, basically, we know that it's been translated and has a vertex of 1, 2. So where's that vertex? 1, 2, which is right there. So if it has a vertex of 1, 2, and there's no stretching, so all we're doing is we're moving this blue graph and moving it to this vertex here, so it's going to be something like that. So it's going to look pretty much like the blue one, except it's going to have a vertex of 1, 2. So this right here is our g of x. Okay, so we're done with this one, and because it has a vertex of 1 and 2, and so we're done. Okay, so now, second part, write down the value of h and k. H is the horizontal translation, and k is the vertical translation. So if you look at this, so this coordinate right here is negative 2, 4. So how do I go from, so this coordinate is negative 2, 4, and this coordinate right here is 1, 2. So how do I go from negative 2, so in other words from here to here? So what is the translation? How much do I have to translate it to the right? So to go from negative 2 to 1, I have to move it 3. So this value right here is 3. And now, how much do I have to move it from this point to down there? So how much do I have to move it? So in other words, how much do I have to move it down from 4 to 2? So basically, I have to move it 2 down. So the values of h is simply equal to 3 because I moved it 3 to the right, and the value of k is simply negative 2 because I had to move it 2 down. Next part, write an expression for g of x. So basically, in order to go from f to g, in order to go from f to g, all we had to do was move it 3 to the right and 2 down. So how can we write g of x in terms of f of x? So if we write g of x in terms of f of x, so all we're doing is we're taking f and we're moving it 3 to the right. So how do we show that? We show whenever we write f as a function, it's going to be x minus 3. And then it's going to be minus 2, right? Because we moved it 2 down. But we want a proper expression. Now, do we know what f of x is? Yeah! We just figured it out right there. This is f of x right here. They told us what f of x is. So what I'm going to do is I'm going to write f of x right here. So f of x is going to be negative, is it x, what was it again? X plus 2. Okay, so it's x plus 2 squared plus 4. So all we're doing is we're taking this argument right here and plugging right into that x, okay? And we're going to play with this, which is basically that first, right? So in other words, this is equal to negative. So instead of this x, we're going to write x minus 3. We're going to write x minus 3. And then there's going to be that plus 2. That plus 2. And we're going to close this bracket here in this square, okay? and then there's this plus 4 over here. Okay, so you might think we're done, but don't forget, we still have this minus 2 over here. So there's that minus 2 over there. So if we want to solve this, this is going to be negative x minus 1, because negative 3 plus 2 is minus 1. And what's 4 minus 2? It's plus 2. Right? And also, another way that we know that this is correct is that we know that g of x needs to have a vertex of 1, 2. And if we look at this equation right here, this is 1 to the right and 2 up. So we know that this is correct. So this is our expression for g of x. Now, finally, on the same diagram, sketch and label f of negative x. So I'm going to use, okay, I'm a little bit cluttered here, but I'm just going to pick like 3 points. So here's how we do it. So here's x, y of the original blue graph right here. So we know that 1 point is, I'm going to pick this point right here and that point right here. So this point here is negative 4, 0. So negative 4, 0. The vertex is negative 2, 4. And then that point is simply 0, 0. So if I'm trying to graph f of negative x, that just means all the x's are, transformed. So it's just the negative x. So the y's stay put, so it becomes 4, 2, 0, 0, 4, 0. So I'm going to use red to graph this one. So 4, 0 is right there. 2, 4 is right here. And 0, 0 is right there. So in other words, if I just had to graph this, this would go like that, go like that. So this red graph right here is basically f of... Okay, so now let's look at number 2. Let f of x equals that, and let g of x be the reflection of f of x across y equals x. Let me just underline that again. Y equals x. What does that mean? In other words, I basically, where have we seen that before? So whenever you have something that's a reflection of f of x across y equals x, it tells you right away, it's screaming at you that these two functions are inverses of each other. So if we have f of x, we can simply find g of x, because g of x is now the inverse of f of x. It's screaming at you because you know that's a reflection across y equals x, so that's telling you that's the inverse. So let's look at this function, y equals 3 minus 2 minus x. So if you want to find g of x, you just have to find the inverse. So x equals 3 minus 2 minus y. Now solve for y. So this becomes x minus 3 is equal to negative square root of 2 minus y. We want to get rid of this negative, so we divide both sides by negative 1. Okay? And I'm just going to write this here. So this becomes negative 1 x minus 3 is equal to the square root of 2 minus y. Now if I want to get rid of that, I have to square both sides. So what I'm going to do is I'm going to square this side. So it's negative 1 x minus 3 squared is equal to 2 minus y. Now I want to solve for y, so what I'm going to do is I'm going to add y to both sides. So this becomes negative 1 x minus 3 squared plus y is equal to 2. And now if I want to solve for y, I have to subtract this side. So y is equal to negative 1 x minus 3 squared plus 2. So this is the inverse function right here. Okay, so this is the inverse function right here. Let me just actually double check that just to make sure. Okay, so that's the inverse function right there. Now the question is, so part B says, write down the domain of g of x. So the best way to do this is go back to the original function and draw it out. So remember, whenever you're drawing a function, always rearrange it. So this becomes negative square root, and you have to factor this. So negative x minus 2, you close the bracket, square root ends there, and then it's going to be plus 3. So if you observe, there's actually two reflections over here, a reflection over here and a reflection over there. So in other words, if I graph this, It's 2 to the right, which is 2, and then up 3, which is there. So we have that. And there's a reflection. So normally it would go this way. So there's a reflection across the y-axis and a reflection across the x. So it's like this. So let's look at the domain and range of this function. So the domain of this function is x is less than or equal to 2. And the range of this function is y is less than or equal to 3. So the question becomes, write down the domain of g of x. We know that g of x is the inverse. So what does that mean? That tells you that for the original function, the range of the original function is the domain of the inverse. So what's the answer to this one? If the range of the original function is y is less than 3, the domain must be x is less than or equal to 3. So that's the solution right there. Okay, so now we're on to the very last problem, which is number 3. Number 3. Let's go over here. So write down the vertex of h of x. Remember, the first thing you should always do is rearrange this. So you get negative 4, and then you go x minus 2 squared, and then you go minus 3. So write down the vertex. We can see right away that the vertex is 2, negative 3. So it's 2, comma, negative 3. So that's our vertex, and we're done. Now, write down the range of this. So the best way to do this is to graph it. So if you observe here, the negative tells you there's a reflection across the x-axis. So this will look like 2 over here and negative 3 over here. So it starts there. And it's a reflection across that, so it's going to go down. So what must be the range? Y has to be less than or equal to negative 3. Now, let's look at part C. This was like one of the actual hardest, trickiest parts. Now, a transformation T is given by a reflection across the y-axis, a vertical stretch by 3, and a translation by negative 2, 4 in this vector form. Let G be the image of H under the transformation T. So this is a very confusing statement. So let's actually decipher what that means. What it's saying here is let G be the image of H under transformation of T. So that means we're starting from H, we end up in G, and how do we end up in G? It's through this transformation T. So we take G, we basically do these things to it, we flip it across, reflect it across the y-axis, we stretch it vertically by 3, then we translate, and that's how we end up with G. So in other words, there must be a way that we can express G in terms of H. Right? So how do we write G in terms of H? Well, there's a reflection across the y-axis, which means we're affecting the x's. So the negative won't be outside, it'll be negative on the inside. Okay? Vertical stretch by 3. So it's a vertical stretch by 3, the 3 must be on the outside. And a translation by negative 2, 4. So negative 2 just means it's 2 to the left. And how do we write 2 to the left? We put another bracket and we write x plus 2. Remember, it has to be always in factored form, okay? And then we have 4 up, so it's going to be plus 4. So this is g of x expressed in terms of h of x. But what we want is we want an expression. We want like a quadratic or something. So if you look carefully, this is our h of x right here. So what we're going to do is we're going to take this argument right here, and we're going to plug it in right there. And remember, this thing is h of x. So we have to sort of be carefully sort of take this argument and put it right there. So I'm going to do that a little bit. I'm going to take a little bit more room. No, I'm not going to use red. I'm going to use blue. So it's going to be 3, and there's going to be some big expression right there. So this 3, whatever h of it, it's going to be right there, and then we're going to tack on the 4 at the very end. So let's deal with this part right here. So we know what's h of x? Well, it starts with negative 4. So we're going to put negative 4 here. Okay, open bracket. And then I'm going to put basically this over here, this argument right here, into x. So I'm going to write that in red. So instead of x, I'm going to write negative x plus 2. Negative open bracket x plus 2. So it's going to be negative open bracket x plus 2, close bracket. Okay? And so that's just going to replace x. Then what's left? There's the minus 2. So I'm going to write that in blue. So it's going to be minus 2. Let's go back up. What do I see? I see a parenthesis, so I'm going to close it. I'm going to close it right there. Then what do I see next? I see a squared. So I'm going to write the squared there. And what do I see next? I see a -3. And so that -3 goes here. So I had the foresight to put these square brackets because I knew it would be a big expression. So you kind of have to know that as well. So we're almost done. We're almost done. We're actually halfway there. So this is 3. So next thing I'm going to do, I'm just going to simplify this expression. So this is going to be -4. And this is going to be -x minus 2 minus 2. So this negative and this positive become this -2. And that -2 was already there. Squared minus 3 plus 4. This is going to be 3 -4. This is going to be -x minus 4, so -x minus 4 squared minus 3 plus 4. Now the last thing I'm going to do is I'm just going to expand. So this 3 is going to distribute to this expression right here and that -3 over there. So it's going to be -3 times 4, which is -12, and that's going to stay as is, -x minus 4 squared. And then there's going to be 3 times this -3, so it's going to be -9 plus 4. And then we just have to simplify this. So it's -12. Do not expand this. You're not required to expand this at all. And this is going to be -5. And if you want to make it a little bit neater, the one thing you can do, and I also recommend that you do, is going to be -12 x plus 4 squared minus 5. And that's our solution. Okay? Now, we're on to the very, very last question. Okay, give a full geometric description of the transformation from G to H. Very interesting. If we look at the previous question, if we look at C, let me just scroll down to C over here. In C, how did we go from H to G? Well, in order to go from H to G, we underwent this transformation, that we had a reflection across the y-axis, a vertical stretch by 3, and a translation by that. Now what are we doing? So in other words, that's how we went from H to G. So now what we're doing is we're going from G to H. So in other words, we're going backwards. So let me just write how we went from H to G. So to go from H to G, we basically we did a reflection across the y-axis, right? Then we did a vertical stretch by 3, and then we moved, I believe it was left 2 and then up 4. Is that correct? Let me just double check. Left 2 and up 4, that's right. And then that's how we got to, and then basically this gave us G. So now our question is, how do we go, that maps from G to H, so how do we go from G to H? So if we want to go from G to H, we just have to go backwards. So if we have to go backwards, so let me just do this. So G, if I have to go backwards, so in other words, I have to go right 2, down 4. If we previously had a vertical stretch by 3, now we have a vertical stretch by 1/3, and we just have to do the reflection again. Reflection across the y-axis, and that's how we get H. Now, this is not what you're going to write if you were to give me a solution. So the proper solution, which I'm going to write in black right now, is, so the answer to this one, which I'm going to write in black, sorry. Should I use black or different color? I'm going to use this new color, this sort of purplish color. So here's the solution. So here's the solution. Here's the solution. Here's how you write it. You're going to write, we're going to go 2 units right, 4 units down, a vertical stretch by 1/3, and finally a reflection across the y-axis. Very, very important that this order is maintained. If you write it in any different order, this solution is completely wrong. So in order to go from G to H, we have to follow this order. So